Hey Jake, I'm going to go over Unit 3 Day 1 homework, and the gist of the notes and this homework is over slope, whoops, wrong button, slope, and rate of change. So if we keep these two things in mind, remember that slope and rate of change, these are things we've seen before. And remember when we're doing 1 through 3, rise over run, and this is the same as the change in y. So the change in y over the change in x. So y is going to change a certain amount, x is going to change a certain amount, and this is our rise over run. So I'm going to take a look at number 2. So the first thing, it says change in y first on top, so rise. We talk about how much this is rising. And when we have a graph like this and we weren't given any points, we look at the graph and see, well, can I look at an intersection and say for sure that it probably lands on a point? So here, it looks like I can for sure say a point lands there and probably here too. So not too hard, find an intersection of grid lines where it lines up, and this point looks like it's at 1, 2, 3, at 1, 3, and this point happens to be at 2, 2. So we do rise over run, and my rise I'll do in this color. So how much does it rise? How much is there a change in height, or y? So it goes down 1, and then it runs 1. So that one's not too hard because it's rising, and I know I'm using the word rise, but since it's going down, it's a negative rise, so my slope, which is rise over run, since I'm going down first, that's negative, and we just went down 1, so negative 1 over, and then we ran 1. So this is just going to be a slope of negative 1. And that makes sense because this slope is from left to right, so going this direction, is going downhill. So this is going to be a negative slope. So maybe one more example. Let's take a look at number 1. So right off the bat, I know that since from left to right, this slope is going up, that this is a positive slope, so I should end up with a positive number. So rise over run, that's my slope. Well, let's see how much we rise. Let's pick 2 points. I think the most obvious ones are here and here. So let's see. We go up 2, so we rise 2, and we run 1, 2. So my rise over run is a positive 2 over 2, which we know is just 1, positive 1. So that's 1 and 2. So you notice when we were doing rise over run that if I'm looking at the rise, so let's say I'm looking at the rise between this point and this point, then the rise is just the change in y. So how much does it change in height along the x-axis? Or not the x, the y-axis. So rise is just the change in y, and run is the change in x. So if I have a graph, it's not too hard to find rise over run. But if I'm looking at points, then I don't even need the graph. All I need to know is that I'm looking for rate of change, which is the same thing as slope. I'm looking for a rate of change of a straight line that passes through each pair of points. And if I know these 2 points, so let's say on number 4, if these 2 points pass through a straight line, then I know I can find the slope, the difference in the y change and the difference in the x change. So looking at our star charts, either one in class or under the resource tab in Google Classroom, we have our star reference sheet. We're going to know that the slope of a straight line has a formula where slope is m. Slope is m, and this is going to be y2 minus y1 over x2 minus x1. And this is still rise over run. This is still change in y over change in x. But this time we're going to decide from what y to what y are we going to, and from what x and what x are we going to. So let's say 4, 9 is our x1, y1. And let's say 1 comma 6 is our second coordinate, x2, y2. Then I just plug in the values. So y2 minus y1 means my y2 is 6 minus my y1 is 9 over my x2 is 1 minus my x1 is 4. So 6 minus 9 is negative 3, and 1 minus 4 is also negative 3. So this is going to be a negative 3 divided by negative 3. Negatives cancel to positive, and 3 over 3 is just 1. So this is going to be a differential change of slope 1. So maybe one more example. With negatives, because it's important that we clarify this. So our slope formula, once again, slope is m equals y2 minus y1 over x2 minus x1. And it doesn't matter which one I make x1, y1. So let's say this one is x1, and this is y1, which means this one is x2, and this is y2. Then it still stands that y2 is negative 1, so y2 minus y1. y1 is negative 5, so I'm subtracting negative 5 over x2 is negative 4 minus x1 is negative 2. So subtracting a minus is the same thing as adding. So this is the same as negative 1 plus 5 and over negative 4 plus 2. So subtracting a negative is the same as adding. So this is 5 minus 1 is 4. 2 minus 4 is negative 2. And this is going to come out to 4 divided by negative 2 is negative 2. So the slope of the line passing through these 2 points is negative 2. Okay. So we use the slope formula for 4 through 12. We use rise over run for 1 through 3. And so if we're given a table of values, so up here they gave us only 2 points. 2 points that the line passes through. But in this table, they've given us so many different points that our line passes through. They've given us a point here, a point here, a point here, a point here, a point here. These are all ordered pairs. So 3, negative 6, 5, 2, 7, 10, 9, 18, and 11, 26. And the trick here is we just pick one. We pick, or not one, we pick 2. Any 2 points on this table and use them in our slope formula. So let's say I pick this to be my x1, y1, and let's say 9, 18 is my x2, y2. So I label them so I don't forget. 5 is my x1, 2 is my y1, 9 is my x2, and 18 is my y2. So if I'm doing slope formula equals y2 minus y1 over x2 minus x1, then my y2 here is 18 minus my y1 is 2 over x2 is 9 minus my x1 is 5. And this is going to equal 18 minus 2 is 16 divided by 9 minus 5 is 4. And we know 16 divided by 4 reduces to 4. So the slope for number 13, this table of values, is 4. And it doesn't matter which 2 points we pick, the slope will always be 4. So on 14 and 15, all you have to do is pick 2 points. Now, 16 and 17, my suggestion is when you read these, draw the picture in your head. Or not in your head, draw the picture on paper to help you. So for roofing, the pitch of a roof, so pitch is another word for slope or steepness, is the number of feet the roof rises. There's that keyword, rises, for each 12 feet horizontally. If a roof has a pitch of 8, what is the slope expressed as a positive number? So the pitch of the roof is the number of feet the roof rises for each 12 feet horizontally. So I have pitch, or the number of feet rising, over 12 feet horizontally. So this is rise over run, because horizontally is our vertical, or not horizontal, it's our horizontal movement or our run. If a roof has a pitch of 8, so that's saying instead of pitch we write in 8 over 12. What is its slope expressed as a positive number? Well, all we have to do is reduce it. So 8 over 12, that'll reduce to, let's see, 8 divided by 4, I can do that. That'll give me 2. 12 divided by 4 will give me 3. And that doesn't reduce any further. So if I have a pitch of 8 over every 12 feet, then I have a slope of 2/3. So for 16 and 17, make sure you go through, read the question carefully, and kind of imagine the picture in your head. And if you need to, you could do a picture. So it's rising 8 feet here. That's its pitch over a horizontal movement of 12 feet. So that means this right here will give me a slope. Rise over run. Okay. Hopefully this helps. If you have any questions, email me and let me know. I will try to help.